Keith Rucker here at VintageMachinery.org. Today we're going to be working on cutting some gears. Been working a while getting ready to this stage and doing various things, getting all my blanks turned. I actually had to do a good bit of work to get the machine ready to go for this, but we're finally ready to cut some gears. And we're going to start on this blacksmith blower repair project. There are three pinion gears that are in there, and these are all basically gears that are cut on the shaft they're going to be on. So and I've already cut my blanks. I've got those ready to go. That was in an earlier video if you want to go back and watch that if you missed it. But anyway, these are all what we call pinion gears, and pinion gears are basically this you have two gears, and one of them is a good bit smaller than the other gear. The smaller gear would be what they call the pinion gear. And all the different pinion gears in this particular project have 12 teeth on them. Now, two of them are a 16 diametral pitch, and one of them is a 14 diametral pitch. I believe that's right. I know it's 14 and 16. And so we're going to have to change some cutters out and whatever to do that. But anyway, we're going to start with these pinion gears. So, but before we get everything set up over here, I want to talk a little bit about gears for anybody that may be wanting to make some of their own, and some of the stuff that you need to know and where you can find the information that you need to make those gears. So again, we have our pinion gears all laid out here, and you can see the original ones that we're going to be copying, and these are just worn, very worn, both the gears as well as the bearing surfaces. The bearing surfaces are probably the biggest problem on these, but the gears are also worn. So we've made the new blanks, and they're ready to go. But before I made the blanks, I had to do, because some people were asking me, so well, how do you know what size to make the areas that you're going to cut into the gears? And that's a really good question. And there's a couple of ways I guess you can go about doing that. You know, obviously, if you got the originals, you can just measure what's on here. But, you know, in this case, we got some significant wear on these gears, so it may not be exactly the right outside diameter. So to verify that information, I basically did a little bit of math and calculated what that should be, and it's fairly easy to do that. So if you're going to cut any gears, you need to have a good reference, and you know, most machinists are going to have a copy of Machinery's Handbook. If you don't have a copy of that, you know, this is a really good reference to have. And there's a whole section in here, I mean, it's probably over 100 pages long, that just talks about gears and gear making. And pretty much any information that you need to know, you can find in here. So what do you need to know? Well, depending on your application, you could start out with knowing several different things. But in a case where you're copying gears, the two pieces of information that you really need to know is, number one, the diametral pitch of your gears and the number of teeth that you're cutting. Now, the diametral pitch is basically the size of the actual gear teeth, and the pitch is, you know, it's going to be a number, and it's going to come down, I believe, to the number of teeth per inch is the way that this works. That may not be exactly right, but I'm pretty sure that's what the pitch is. You know, in my book here, we got a showing like starting at a 3 pitch going up to a 20 pitch, and how as you get to a higher number, the teeth get smaller. And you can use this is to scale, so you can use this right here to determine what pitch your teeth are. Now, what I've been using is I actually have this little gear gauge, and this is made by Boston Gear, and you can find these. They're actually fairly expensive. I found this one at a tool meet and got lucky. I think I paid about 10 bucks for it. But these are basically just little gauges that have the pitches on there, and let's zoom you in here. We'll show you how this is used to determine the pitch. So we'll start with this bigger gear here, but you can basically just take this little gauge and come in here and find the one that matches. You know, we go to this one here, that doesn't mesh, and you know, through trial and error, you can determine which one actually fits. So this is kind of set up like a rack in the gear, and you just see the one that fits, and it's stamped on here. That's the number 16, so this is a 16 pitch on this gear. My other gear is this one here. If you look, that 16 pitch doesn't fit, and let's see, we go to this one here. This one is a 14 pitch. So you can determine real quickly. It's a little bit easier to use this on a bigger gear. You know, we go to the pinions, and it's the same thing. You know, there's your 14, and there's your 16. That just walks right down through there. Get that in the screen where you can see it, and that might help. So anyway, we've determined that. We've determined the pitch, and then of course the number of teeth, you just count them. In fact, you can probably see on here where I put little dots. I took a little marker and went around that and just counted the number of teeth and double counted them and make sure I had them right. But with the pitch and the number of teeth, then you can start doing calculations to come up with what the dimensions need to be. So to help me work through this, I basically went into Microsoft Excel and created a spreadsheet that will do my calculations for me. But all of the formulas to determine this came right out of the Machinery's Handbook, and anybody can look up in there. You can go online and find these formulations as well. I got all the formulas right out of the Machinery's Handbook. So up here at the top, I put in my diametral pitch, which will signify by P, and the number of teeth, which will be N. That's the normal nomenclature for those. I also got pressure angle on here, which all my gears are going to be 14.5 degree pressure angle, and I'm not going to talk a lot about pressure angle. Generally speaking, most gears are either 14.5 or 20, but it's kind of hard to measure that. And again, I'm not going to talk a lot about that. If you want to find out more about pressure angle, you know, get out your Machinery's Handbook or go online. But I do know that mine are all 14.5. So, you know, one of the questions was what is the outside diameter of the piece that you're going to turn? What does it need to be? Well, it's fairly easy. You just use a formula, number of teeth plus 2 divided by the pitch, and you can calculate what the outside diameter should be. In this case, it comes out to 0.875 for that gear. And then I actually scanned, to help me, a diagram out of the Machinery's Handbook and actually put it on this so that I could help remember what's what. Most of these other measurements are not necessarily important to know when you're machining, but some of them are, some of them are, but some of these are used later on in other calculations that I make. But I went ahead and calculated everything out. So the big thing is what does the outside diameter of the gear need to be? And then also, what is the depth of cut that my cutter needs to make as I'm cutting these, so that I kind of have a target to go for. And if you look at the hole depth of the tooth, it's just simply 2.157 divided by the diametral pitch, and that'll tell you how far down you need to go. You also need to factor in some backlash. You know, these gears mesh together. If you cut them just right to the book, there's absolutely no play between them, and the gears will bind up. So you actually need a little bit of play, a little bit of backlash. And I can calculate, there's a formula to calculate what the backlash should be based on the number of teeth and the pitch, or actually based on the pitch, which is, you know, in this case, you need about 0.03 of backlash. And then again, I had another formula here, the depth of cut to obtain backlash, so is 0.137. So I need to cut 137 thousandths deep with my cutter to get where I need to be. So anyway, I created all this. There's the formulas that I used right here to come up with all this stuff, and that's how you do it. And on these outside diameters, you know, I went back and measured the original gears to verify that I'm in the ballpark, or, you know, and quite honestly, I was right on the money. The measurements were the same, which tells me that I was doing it right. So once you know what your diametral pitch is, you know how many teeth you've got, the next thing you do is get the right cutter to cut these. And there are a series of what we call these involute cutters, and if you look at the profile, it kind of matches that little shape, that involute spline of the gears that you're cutting. But because this number of teeth, you're going to have different diameters of gear. You know, one cutter for one pitch doesn't cut it. You have to have multiple cutters because the geometry of that tooth is going to change depending on the number of teeth you have. And there's actually 8 different cutters, generally speaking, to be able to cut a range of teeth for each diametral pitch. And again, you go to your Machinery's Handbook and you can look this up, and there's a little chart in here. and we'll zoom you in there where you can see that. So there's 2 charts in here, and actually I said there's 8. Back a long time ago, they used to have half series, so there was actually a gear you could get, or a cutter in between each one of these numbers. But generally speaking, most of them are just going to be in the 8 cutters. There may be some halves that are still out there that you can find, at least in old stock. I don't think you can get it in new cutters anymore. But what you look at here is, of course, for each diametral pitch, there's the number cutter 1 through 8, and each one of them cut a different range of teeth. So I know that I'm going to be cutting 12 teeth, at least in this first one. So if you look, the number 8 cutter cuts 12 to 13 teeth. So that's what I have, is I have a cutter for diametral pitch 16, and it is a number 8. And that's this particular cutter right here. And you can kind of see the profile on there of what that's going to cut. So all of my 12 pitch teeth, at least for, and I got both 16 and 14, so I got 2 different number 8s depending on the pitch. My other bigger gears, one of them is 40 gears and one of them are 40 teeth, and one of them is 50 teeth. And it turns out that both of these will be number 3s, so 35 to 54 teeth. You'll use the number 3 cutter. But again, I had to get 2 of them, one for a 14 and one for a 16 diametral pitch. So I've got all my cutters. I know my diametral pitch, I know my number of teeth, I've got my calculations all worked out for each one of my gears. So I've got my homework done. Now I'm ready to start setting up the machine to start cutting gears. The next step is to get your dividing head set up for the number of teeth that you're going to be cutting. And again, I told you we're going to be doing, we're going to start with cutting 12 teeth. All the pinion gears have 12 teeth on them. We have different diametral pitches, which we have to change cutters, but as far as the dividing head goes, they'll all be 12. So the first 3 are all going to be, the dividing head will be set up the same. So this is a Brown and Sharp type dividing head. I don't think this is actually made by Brown and Sharp. I think this was one of the early clones. Now this dividing head was invented back in the late 1800s, early 1900s. I don't remember the exact year. But when the patents ran out on it, it was such a good design that a lot of companies started basically just copying this thing and making their own versions of it. And even today, there's several of the import companies that are selling Brown and Sharp type dividing heads that is, the design has been virtually unchanged for 100 years, which is a testament to this design. It's a good design. This one here is an older one. I don't know who made it, though. It's not marked, but that's not important. But what is important to know about this dividing head is what the gear ratio is between this handle and what's turning up here. So this part right here will be making revolutions around, and what we want to do is we want to be able to index this thing exactly the right angle for each number of teeth. But instead of doing it in angles, we're actually using ratios to calculate how far we need to move this. So this particular dividing head is at a 40-to-1 ratio, and most of the dividing heads out there, that's what they are, 40-to-1. I think the actual Kearney Trekker dividing head that goes with this machine is actually a 5-to-1 ratio. I don't have that one though, so it doesn't matter. We're going to be using 40-to-1. So what that means is that when you turn this handle here, you have to turn it 40 times to cause the part back here to make 1 revolution. It's 40-to-1. So what we need to be doing is we need to figure out how many times we need to turn this crank to get it to turn where you will be stopping 12 times. So again, you can use math. You take 40 divided by 12, you can get a number, but quite honestly with dividing heads, what you really want, instead of having a decimal, you want to have fractions. You really want to do your math in fractions. So anyway, you do the math, and what you come out with is that you need to turn this handle 3 1/3 times to get 1/12 of a circle. If you do it on the calculator, it'll be 3.33333, or you can use fractions, like I said, you'll come out. And then what you have to do is, you notice I got this plate back here, and this plate has a series of holes in it, and each one of these series has a certain number of holes in a circle that are around. The first one is I see 33. All right, so the bottom hole goes from 21, 22, 27, 29, 31, and 33. That's the number of holes that are around this thing. And I'm in the series that has 33 holes in it because I can actually come up with a third out of that number. And I could probably get that out of some of these other holes as well. But what I want to do is I'm going to go 3 1/3 times. I'm not going to stop in every hole, but I'm going to be stopping, and because it says 33, it's going to be 11 30-seconds, or 11 30-thirds, excuse me. So I go, I've got this a mark, so I'm in this pin. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the 11th hole, which is 1/3. I've got this little the little scepter arm set so that I know that if I push this one up against this pin, this will be the next pin I need to go to. But I got to go 3 full revolutions in the part. So I go 1, 2, 3, and a third. Drop it in that pin. I move my scepter arm around. 1, 2, 3, and a third. So on and so on and so on, all the way around. And you'll do that 12 times, and you will come up with a full circle. You can cheat. I've got a table here that basically shows you for the number of divisions, what plates you need to use, and how many you need to make. So for my 12, it helps me use a 33 plate and go 3 11 30-thirds. We're going to be cutting a 40 tooth gear. Remember, it's a 41 ratio. So on that, it's just 1 revolution and go back to the same hole. So you can use any plate you want to use as long as you go back to the same hole every time for the 40s. And then on the 50s, I'll use a 20 plate, and it is 20 16/20 is what I'll have to do to cut a 50 gear. So I'll have to change plates for the 50 gear. I don't think I've got a 20 on this one, but I have another plate over there that has 20 holes in it. So next thing we need to do, of course, is get our footstock set up on the machine so that it is set up where it's exactly at the right height here. And I have some adjustment in this. It can go up and down. It can tilt back and forth, whatever. And I apologize. I did this off camera. This is my part that's going to go in here. When I was setting this up, I actually what I used was a reamer, a long reamer that had a nice ground shank on it, had 2 center holes, 1 on each side. And I set it up on here, and basically I took the dial indicator and went back and forth until I had that shaft running perfectly straight across there. And like I said, I can bump this around up and down and get it right where it needs to be. It's set now, so we're good to go. That part was done off camera. This is the part that we're going to cut, and it's going to go between centers. And of course, we're going to turn this over here, and that's going to turn that part. But in order to keep that part to turn, there's nothing that's going to make it turn exactly the right ratios or right index time. So we've got a dog drive plate, and we're going to put a lathe dog on this to actually help turn it. So let me take it back out. And this is the lathe dog. I've got a little piece of brass shim in here because I don't want to mar the surface up. And I'm going to tighten this down good and tight. Let me get a wrench. And we will put this back between centers. And this time, notice that this lathe dog is, or the lathe, the dog is going up into this part behind that's going to drive it. The part that drives the lathe dog. I'm going to put it back between centers. I want this to be tight, but not too tight. I don't want it to be putting too much pressure on the dividing head. So now there's a little set screw up here, and we're going to tighten this screw up as well. And that's going to take any movement out of this at all. This doesn't need to be super tight, but it does need to be tight. So now, as I'm turning this, notice it's turning that lathe dog around, and it's making sure that that part is turning with the dividing head. So now we're ready to put the actual milling arbor in. And all of our cutters that we're going to be using today are fit on a 1-inch arbor. So I've got my 1-inch arbor here. This is 50 taper up in here, and I always like to kind of clean this taper out anytime I come in here. You know, it's open to the elements, and you're going to always get a little bit of dust and stuff up in there, potentially even some trash. Same thing here. I'm going to wipe down the mating part, and this 50 taper arbor goes right up in there. And then we'll go around the back, and I'm going to tighten that up using the drawbar, and that'll be holding it firmly in place. Next step is to get the right cutter to go up on the shaft. And again, I've got 4 cutters for this job, and to kind of make it a little bit easier on me, I went and wrote on each one of my parts what the pitch is. And I know this is a 12 pitch just because this is a pinion gear, it's a small one. And I've got the cutter here, and it's written right on the cutter, it's scratched on here, DP16 for diametrical pitch, and this is the number 8. And again, the number 8 is the one that cuts 12 to 13 teeth. So I've got the correct cutter for this particular gear, and now we're going to go ahead and put it onto the arbor. So I'm going to pull my nut off here, pull off my spacers, pull off my running bushing, and pull off some more spacers. This cutter has a keyway on it, and there's a key on my shaft or on my arbor here. So now that cutter is on there, and it's geared in or keyed into place. And we'll put some spacers back on here. Put my running bushing back on. You know, a lot of people will run this running bushing all the way out at the very end. The shorter that you can make this section here, really the more stable your setup is. And quite honestly, I could probably even shorten it up a little bit more than this, but this is going to be plenty good. But notice, you know, my arbor or my bushing is not at the very end. It doesn't have to be at the end. And this is a rather long arbor here. I'd almost wish I had a shorter arbor because I really don't need all of this for this particular job. Go ahead, we'll tighten that up real good and tight. All right, so now that should be running good and tight right in there. Next thing I want to do is put the actual overarm support that will run on this bushing. So I'm going to come over here now and extend out the overarm supports. These are on a little rack and pinion. I got a little hand wheel over here, and I'm just going to extend these out pretty much all the way to the end. And let me go grab my overarm support. Again, before I put it on there, I want to wipe these down, make sure they're good and clean. Put that right on the end, and I'm going to go ahead and tighten this nut up right here. Now, one thing I have found is as far as getting this onto your running bushing, if you try to slide it up on all 3 pieces, on the overarm supports and on the running bushing all at the same time, it's hard to get everything lined up just right. But when you tighten this down, this should be exactly at the right height to fit on the bushing. So now I'm just going to pull this back over the running bushing, and see, it just went right on. But I'm going to oil that up real good first. Make sure I got plenty of oil in this running bushing to start with. And there we go. Next thing we'll do is we're going to tighten up the overarms. There's 2 bolts up on the top here that will tighten these up and make them just as rigid as we can get them. My next step here is I need to get my cutter centered exactly over the center of this part. And to do that, what I'm going to do is I've come in here and I've got a machinist square that's running right up to on the edge of this part. I had to go put a 1, 2, 3 block under here because this is a 5.5 inch machinist square, and I really needed about an 8 inch or at least a 6.5 inch. So anyway, maybe I need to find me a bigger machinist square. No big deal. But what I'm going to do is I'm going to come in here with the cross feed now, and I'm going to pull this over until that square just touches right there. And to help with this, you can take and shine a light behind this, and I'm gonna get in the way of the camera with the light because of my arm, but anyway, you can see that, but you want to get it right up onto the against the side right there. So I've set my dial indicator up on 0 where we were on the other side. I've moved my scale around to the other side of the cutter now. And what we're going to do is we're just going to move everything over and keep track of how far we've moved it to get everything to touch on this side. So that's 100, 200, 300, 400, 500, 600, and we are touching right there. So I'm 655 thousandths. All right, now to find center, I take that 655 thousandths, I divide that in half. I've got my calculator here, it comes out to 3275. So I'm going to re-zero this out right here, and make sure I got a good 0. There we go. 1, 2, 3, 150, 60, 70. No, excuse me, 320. So 325, 6, 7.5 right there. So now I'm going to lock this table down right there where it needs to be, and the cutter should be running right on center. So we're getting ready to start cutting here, but before we do, we need to touch off so we can get our depth. So I'm just going to raise the table up until that cutter is just touching, and I'm going to just ease into it, and that's it. Do that again. All right, we're just touching right there. I see a little mark on there, and that's going to be 0. So we're ready to dial in our depth of cut, and according to my calculations that I had done before on my printout for this gear that we're cutting 16 teeth, I'm double checking on my mark there, 12 number of teeth, 16 pitch. I need to go a total of 137 thousandths, but I'm gonna purposely go a little shy on the first cut because I want to get some measurements and verify everything. So I think what I'm going to do is right now we're just going to go 100 thousandths on this first cut pass, and then I can come in here after I've done my first round, make some measurements, and make sure we're where we need to be. So we're right here on the verge of making our first cut, but before we do, there's a couple of little quick things I want to mention about the dividing head. So number one, when you're cutting this or when you're turning this, you always want to turn it in the same direction. It doesn't matter if you're going left or right, as long as you always go in the same direction. There's a certain amount of backlash in the gears in this thing. So if you have to go forward and then back up and then go back, you need to make sure you take that backlash out. So, you know, go forward, you have to back up to where you can feel everything moving. Go past the point of backlash again and come back until you feel tension, and then go into the pin that you want to go into. As long as you take that backlash out, you're fine. The other thing is you can't see it, but on the back side of this dividing head, there is a lock that locks the everything in place. So every time you get it set, you want to lock it, and that will also take any backlash out from in this to keep it from turning ever so slightly while you're cutting. So we're ready for our first cut. little bit about my feeds. You know, I can calculate what the feeds need to be using that calculator that I have, but quite honestly, feed is something that I just get a feel for. So I'm going to start out in the lowest feed, which is a 1/2 inch per minute, and we'll probably ease that up. That'll probably be too slow, but I probably won't go more than about an inch, inch and 3/8, or inch and 3/4 per minute, somewhere along in there. But we'll play with it and get it to where I feel like it sounds right, and then we'll leave it on that feed rate. All right, let's let it roll. Feed is on. Put a little bit of oil in there. And it's starting to cut. I'm going to take my feeds up to 5/8 per inch. I'm going to take it up to 3/4 per inch. One inch per minute. Inch and 3/8 per minute. Inch and 3/4 per minute. We'll probably leave it there. I'm gonna let that cutter go until it's past the center. All right, it's through cutting. And back it out. Back over to the dividing head. We'll release our spindle lock. And we're going to go 1, 2, 3, and a third. And we're ready for our second cut. Let's lock that back down. All right, so now it's time to do some inspection. We're going to actually remove the part from the mill. and take it over and do some measuring. So now it's time to start doing some measurements and figure out where we are. And there's several ways to measure gears, but probably one of the best ways to do is to actually use a system called measuring over pins. So, and this is a diagram kind of showing it where you have an even number of teeth. You take a pin and you put in between the two teeth, and you actually make a measurement over those two pins, and that will give you a measurement to shoot for. And again, if you look at Machinery's Handbook, there are all kinds of formulas and stuff to determine what you need to be, what size pin you need to use, and what these measurements need to be. And I have done the calculations, and for this particular diametral pitch, a 16, you should use a pin that's 105 thousandths. And there's a formula there, 1.68 divided by P. And I will say there's actually several charts. There's several different pin sizes you can use, and in the later versions of Machinery's Handbook, they actually have tables for multiple pin sizes. In my older version of Machinery's Handbook, this is the only one they give, is the one using the 1.68 divided by P. And that's the one I'm using here. But again, you can use your Machinery's Handbook and use the formula for whatever ratio you're working with. So I've got my two gauge pins here, and these are both 105 thousandths, and I'll take one on the top, one on the bottom, and we'll use a micrometer to measure across those distances and figure out where we are. So I determined while I was playing around with this that I didn't have enough hands to do this job right. So I have resorted to lightly clamping my micrometer in a vise here. And I've got the two pins in across from one another. And I'm going to come over here with my micrometer, and we're going to get a measurement across those pins. And we are measuring, let's see. Let me, it's just awkward with the not being able to get there. I'm trying to stay out of the way of the camera. So it looks like we're measuring 0.960 and about 3/10. So we got 0.960 and 3/10. I'm just going to work with thousandths right now. I'm going to subtract from that what I was going for, my target, which is 0.875 over the wires. So I've got about 85 thousandths total to go, but I need to divide that by 2 because we're going to take it off of both sides. So we need to move the mill up 42.5 thousandths. We should be right on the money. So we'll go over here and do just that. So let me unlock my table, and we'll come up 42.5 thousandths. It should be somewhere right along in there. And when I locked it, it moved it a little bit, so let me back off. All right, that's plenty close enough right there. I didn't really mention this when I took it off, but notice I left the dog on here, and that's real important when you take this out, is you leave that on so that if you have to take it out of the mill for whatever reason, you can put it back on the mill and get everything indexed back up right where it was before. And that's exactly what we're going to do here. We'll tighten the tailstock back up, and we'll tighten this back up. And now we should be cutting back in those exact same grooves that we cut the first round with. And we got our depth set to the proper depth now for finished cut, so we'll knock these out. So we've got our pins back in here, and come in and make a measurement. Right there, and that's right on 875, which is right on the money. That's perfect. Very happy with that. All right, guys, one down, a bunch more to go. So I think you've seen the process. I will probably cut at least the rest of these little pinion gears off camera, bring you back at the end, and we'll show you a few things on cutting the bigger gears when we get to those. Just finished up cutting the last of these pinions, and these are all done now. I thought I'd give you guys a quick peek as to what they look like. Done some measuring. Everything seems to measure up all right on these. Very happy with how it's turned out. So we're going to move on, and we'll probably start next getting the big gears cut. And I got a little bit of stuff to get ready for that. Probably going to do that in a standalone other video, just simply because I'm not quite ready to get started on that yet, and we're going to probably go ahead and get this one pushed up. So we will be back soon and show you those other gears being made.